Welcome back, Environmental Epidemiology class, and in this particular video we're going to focus on an example of a case control study. And this example, of course, is going to relate to the COVID-19 disease that's upon us. And as we cover this, part of what I'm going to focus on is what makes a case control study different from something like a cross-sectional study, correlation or ecologic studies, experimental trials, or case series. So, the case control studies are some of the most common ones that are out there, cross-sectional probably being even more common. And the example we're going to focus on is this particular paper. It's a preprint right now in the Lancet. It's been out there for a little while. About 450 people have downloaded it in the world, but it's a pretty, novel paper in a lot of regards. And we know a lot about Lancet being a great journal. It's got an impact factor of 59. If you were to do the Google journal metrics on it and were to look up what the impact factor is for it, it'll show up on the first page, 282. So probably the fourth most cited journal in the world. And out of all the people in the world looking at this article that's scheduled to be printed, only 447 people have ever downloaded it. So looking at this particular article, we're going to focus on the risk of death of this particular virus among those who actually get infected with it. When a person submits a manuscript to a journal, this is actually how it actually tends to look. Let me zoom. View, full screen mode. All right. So if you ever submit an article to a journal, this is how you get your automatically generated thing once you take your Word document. A lot of them actually look very much like this. So here's all the information that we need. It's all in here. I'm going to just skip down to the tables because that's the most important part of this manuscript, in my opinion. So this is a case control study, and it's actually kind of a case control study times 2. Here are the cases and here are the controls in kind of study 1, and then here are the cases and here are the controls in study 2. So what makes it a case control study? So cases have to meet the case definition for the study. So whatever the study is about, you want to have a case definition for who are your cases. So in this particular study, the cases are people who had COVID-19 and died. Those are the cases. Who are the controls? Well, the controls are people they're comparing them against who did not have COVID-19 and died. So could they have developed COVID-19? Yes. But did they die? No. Could they have had some other disease? Yes. Did they have COVID-19 and die? No. Case control studies have a case definition. Many of them are done on things like heart attack. Cases are people who had a heart attack. Controls are people who didn't have a heart attack. When we do our case control studies, usually it's good to identify your controls from a similar population where they have some sort of thing in common. The selection of controls is a particularly important decision. When we select our controls, we want to make sure they have as much in common with the cases as possible, with the exception of actually having the case or the case condition. So sometimes they come from like a hospital that's at the same place where the cases were observed. In this particular study, we have the COVID-19 death group, people that died with it. We have people in the Wuhan seafood market group that got COVID-19. So they're comparing those that died versus those that were at the seafood market. So here are our cases, and here's the control group. The mean age of the cases of the people who died, the mean age, the average age was 70, or 71.6. The median was 70. The median of the seafood group was 49. Most of the people in both studies were men. So people who got sick at the seafood place were guys. People that got sick and died at the hospital were guys. We see any morbidities, having any other type of condition, being much higher, 68% versus 31.7% in the seafood market group. We look at other things like COPD, or chronic obstructive pulmonary disease. A lot of people think of emphysema. Only 1 out of the 41 people, 2.4% versus 15.6%, almost 7-fold increase from here to here. Now, this is a case control design. You can't use risk ratios or rate ratios. You have to use odds ratios to analyze case control studies for a lot of good statistical reasons. When we look at the actual odds ratios, this study's in Lancet, and it doesn't even have adjusted odds ratios, and it's got small numbers, so that tells you how important this study is despite all of its limitations. When they compare the 41 seafood people versus the 32 people who died, the people at the seafood market who got the disease but didn't die versus the people who got the disease and did die, what do we see? We see that the age, being over 65 years of age, was a serious risk factor. 26-fold increased odds of dying if you're over the age of 65. The confidence interval does not include 1. It's all harmful. All right? Next, when we look at being male or not, 1.3-fold increased odds, but not statistically significant. No difference there in the frequency of dying. So gender did not have, or no difference in the frequencies between being in either group based on gender. When we go down to any morbidities, 4.7, 1 is not included, so we see a statistically significant increased odds of having any, or dying if you had any morbidity. Other things, hypertension, so elevated blood pressure, that was associated with an increased odds, but barely makes the statistical significance. But that's okay, you got a small population. Other than that, COPD, increased risk or increased odds, but we didn't have enough people in the study to show the statistically significant effect. So age, definitely a big factor. Having any underlying disease condition was a big factor. Elevated blood pressure was a big factor. Cardiovascular disease, 5.1-fold increased odds. That was significant. So those are comparing the seafood group versus the people that died. The COVID-19 people from the market versus the people who had COVID-19 and died. Here they compared them against people at the hospital. And again, you know, we saw age being the risk factor, people over the age of 60. They had data on these people and data on these people over the age of 60 at the hospital. 9-fold increased odds among those who were over 60 of dying. The other ones, this one almost achieved significance, but did not. So this population, you know, showed a lot of differences from that group. There were other ones that they did. Shortness of breath. People who experienced shortness of breath both at the hospital, comparing those at the hospital and those at the seafood market, we saw a big increased risk. So if you experience shortness of breath, they had 11.8-fold increased odds of dying. Among those who had COVID-19, if they experienced shortness of breath, comparing the market versus those who died, we see that shortness of breath was a big risk factor for whether or not they actually died. The people here experienced a lot more shortness of breath compared to these people and these people. So that's kind of the major highlights of this particular paper. It's one of the ones where when you do crunch the odds ratios, some of the numbers, even those crude odds ratios, didn't quite match up. So there's some missing data where maybe one person has not got complete information here and there. So the odds ratios match up pretty closely and are right on almost all of them. But there's a couple of them, like age, where I think there's like one person missing where they didn't have their age but still included it. So the stats aren't perfect in it and are probably going to get revised. But overall, a pretty good example of a case control study that used the COVID-19. There'll be more of those case control studies that come out in the near future, but right now there's not very many of them that have been published yet. So I'll stop the video here